We're now going to discuss the transformations of exponential functions. So it's going to essentially follow the same format as previous transformations. So f of x, and these letters are all going to do the same things that they did before. A is going to be a vertical stretch or a compression. If it's negative, it's going to be a reflection over the x-axis. The k is going to be the horizontal compression or stretch. And again, if it's negative, it's going to be a reflection over the y-axis. This will move it left or right. This will move it up or down. There's a b here, which is the base. And kind of like whether, regardless of what the base is, whether it's 2 or 3 or 7, the base doesn't really change too much unless it's between 0 and 1 or above 1. Then it's different. So that's kind of our overall thing. Let's go through some actual examples. So let's say I have f of x equals 2 to the x plus 7. So what we're having is, this is moved up 7. That's an up 7 type situation. And what's going to move up most importantly is going to be the asymptote. So the asymptote is going to be, I shouldn't have put a dot there, but that's going to be at 7. And then it's going to be just a whoop, like that over there. Key features of this graph, it's going to be increasing. The asymptote, it's kind of on the graph, but just in case, it's at y equals 7. The domain is all real numbers, as it will be for all of these. And the range, it's going to be that y is a real number as long as it's bigger, strictly bigger than 7. Okay. F of x equals 2 to the x minus 3 plus 1. So what's happened here? The asymptote has gone up 1. It's moved to the right, but for exponential equations, so you kind of have the y-intercept over there, and it's just moved over to the right. But it's not going to look too much different. It's going to look still roughly like that. The asymptote went through 1. That's a little bit hard to see. And what do we know? We know that it's increasing. The asymptote is at y equals 1. The domain is all real numbers. And the range is going to be all real numbers as long as it's strictly greater than 1. Okay. So the next one is going to be, we're in example 3 here. Okay, I've ramped up the difficulty quite a bit here. So it's gone up 3. So the asymptote is going to be at 3. Now, kind of before we did that, we have a minus here. I'll make it clear. I'm not sure if I made it that clear. We have a negative, and we have the half. So what does the half do? So as a recollection, when you have, I'll kind of sneak this onto the thing. If you have 1/2 to the x, then that's going to look like a decreasing. It's going to be going like that. That's what the 1/2 x looks like. But now with that negative in front, what's happened is this thing has flipped over the x-axis. So when we flip it over the x-axis, it's going to look like this now, and then we're going to move it up 3. So what ends up happening is it's going to look like that over there. And so what do we see? In this case, the graph is increasing. Unlike the other ones were increasing to infinity. This one's increasing towards the asymptote, but always increasing. The asymptote is at y equals 3. The domain is still all real numbers. The range in this case, it's all real numbers, but it has to be less than 3. So y is going to be, and it never gets to 3, so y is strictly less than 3.